Good morning, everybody. So, I hope you all solved yesterday's questions. That was electrostatic. Some extra 4 questions were there. I hope you all solved it okay only, because nobody asked me any doubt. And today we are starting the chapter capacitors. As you all requested, I am not going too much into theory. We will directly go to PYQs only by just like revising what are the topics in capacitor. Okay, if anyone needs much more explanation, please put in the chat box. I will be explaining it. So which topics we will be revising today are capacitance. Generally, what is capacitance? Energy stored in capacitor, parallel plate capacitor, combination of capacitors, and dielectric in capacitors. These are the major topics from which you will get questions. Okay, capacitance is basically like some equations you can see here. You can see that C equal to Q by V. Okay, when what is the like capacitance means, if you are storing 1 coulomb in 1 volt, that is called as like capacitance of a capacitor. Okay, now or in 1 volt, if you are applying 1 volt to a capacitor, how much charge will be stored in it? That is the capacitance meaning. Okay, so these are the formula. Q is equal to C into V, V equal to Q by C, C equal to Q by V. So this is the relation between them. But the thing is that if you change from this equation, if you are considering capacitance equal to Q by V, okay, let's say that I am changing Q, then C will not change. C will be constant only. Why? Because if I am changing Q, according to that V will also change. Okay, since both will change together, C will remain constant. Okay, so C does not depend on charge or volt. This you should remember. Okay. Next is energy stored in capacitor. Based on the previous formula only, we have derived this during when you are studying this chapter. Energy stored in capacitor equation is half QV, or it can be written as half CV square or half Q square by C. These 3 formulas we can use to find energy stored in a capacitor. Other than this, we have to see energy density also. Before I told you what is energy density? Energy stored per unit volume, that is energy density. So that is equal to half epsilon naught E square. Same formula we revised in electrostatics too. Okay, so if you have energy per unit volume, you can equate to this. Okay, next thing is parallel plate capacitor. This is the capacitor like we will be using most. Like we will be solving questions based on. So you can see that for a parallel plate capacitor, capacitance equal to K epsilon naught A by D. In this, A is the area of the parallel plate, D is the distance of separation between 2 plates, epsilon naught is permittivity of vacuum, and K is dielectric constant. Dielectric constant can also be said as relative permittivity, that is Em by E naught, which is epsilon R. Dielectric constant is same as relative permittivity, that you have to keep in mind. Okay, now if only air is filling the gap between the capacitor, means C will just be equal to epsilon naught A by D. Okay, so from this what did we understand? Capacitance depends on dimensions of the like physical dimensions of the capacitor. Okay, how we are making it, area, distance with separating them, and what medium we are filling in between. C depends on all these things. It will not change with respect to Q and V. Okay, next is, this is a general question that we can see, that is first we are charging a capacitor. Okay, initial connection will be like this. There is a capacitor, it is connected to a cell. Okay, so this will get fully charged. Okay, this will get fully charged. Then we will remove it. We will remove it and connect to another capacitor. When we close it, what will happen? Charge will flow, it will get distributed. It will distribute in such a way that both the capacitor will be at same potential. Okay, so if you connect this across this, both will have same potential V. So this is C1, this is C2. We know that charge on 1 will be Q1, charge on 2 will be Q2. This will be equal to total charge Q, and both are having same potential also. With this, we can find what will be the potential across both. What will be the value of V? You can see that C1 V1 plus C2 V2 divided by C1 plus C2, which means if both of them are charged, it was having initially potential E. Second one, if it is uncharged, it will have V2 0. Substituting those values, you can find what will be the final potential across them. Now, when we do this, what will happen is that energy stored in before and after will have some difference. Energy stored before will be more, and when we connect it to another capacitor, the total energy stored in both will be a lesser value. Some energy will be lost as heat. That heat loss of energy we can find using this formula, half C1 C2 by C1 plus C2 into V1 minus V2 the whole square. Okay, this we are deriving, we don't need the derivation but. So two cases, one is finding final voltage across the capacitor, next is finding what is the heat lost during this process. Okay, is there any doubt regarding this? Hello, are you guys listening? Please give me a thumbs up. Okay. Next is combination of capacitor. Again, I am not going further into explaining this. If capacitor is connected in series, we will add the reciprocal. Okay, 1 by C1 plus 1 by C2 equal to 1 by C equivalent, connected in series. Okay, connected in parallel, we can directly add total capacitance equal to C1 plus C2 plus C3. Okay, I don't think you need further explanation for that. Next, this is just for as a concept you need to learn. You won't get any numerical based on this, but you need to know this concept. Okay, the thing is, equation for charging a capacitor. When you connect, what happens is that we have a circuit and the switch is open. Okay, and resistance R is there. This is having cell is having V voltage. Now just there are two cases for a capacitor with the DC source. You are studying capacitor again in AC current. There the application is different. In DC source there are two cases. First case, switch just on. Okay, and second case, steady state. Okay, these two cases you have to see. When we just switch on the switch, this circuit will behave as like this. Like capacitor can be assumed to be a conductor. Okay, this circuit will become like this. So we can say that current through the conductor will be equal to V by R. Okay, so first case, switch just on, capacitor will behave as a normal conductor. So you can close the circuit like this. Second state, switch has been on for a long time, for 10 minutes you kept the switch on. Then what will happen? Capacitor will be having maximum voltage, right? It has stored maximum charges. Then current in steady state will be 0. Okay, in this case capacitor will be fully charged plus minus, potential V will be there, R will be there, but current through R will be equal to 0. So these two cases, based on this you will get question, but with this formula you won't get question. Okay, these formulas are for like when you on the switch and between steady state capacitor is slowly charging, right? During that time what will be charge on the capacitor, it is based on that. Okay, so charge on capacitor you will get with this formula, that is Q is the maximum charge it can store, 1 minus e to the power minus t time divided by RC. As you can see, there is a resistor and capacitor. Here there is one thing called as time constant tau equal to RC. When t equal tau equal to RC, which means t equal to RC, this will become what? Q equal to Q naught into 1 minus e to the power minus 1. It will become this value. This is same as Q will be equal to 67% of Q naught at this time. That is called as time constant. Again, if you are taking current first it will be maximum and finally it is 0. So current will start from the maximum value and exponentially decrease. That's why current equation is this. Okay, while charging a capacitor. Now discharging means suddenly we switched it off. So again current will start at the maximum. Okay, so current equation will be same only, negative sign because current will be flowing in the opposite direction. Discharging of capacitor, here 1 minus will change to just Q naught into e to the power minus t by RC. Is there any doubt? Numerical or problem solving will come based on these two cases. This for concept knowledge only. Do you have any doubt? Okay, I guess not. So we can move on. Next is placing a dielectric in capacitor. We already discussed if any dielectric is placed initially if C equal to epsilon naught A by D. Okay. After inserting the dielectric, C dash will be equal to K epsilon naught A by D. Okay. So epsilon naught A by D is C. So we can say C dash is equal to K into C. Okay, this is how the capacitor changes when we insert a dielectric, and the capacitor will be increased. The capacitance will be increased if you insert a dielectric. Okay, screen is not clearly visible. 1 second. Is it clear now? Is it not clear for all? Okay. Okay, so capacitance will increase by K, okay, when we insert a dielectric. Now, if you are seeing partially filled dielectric, which means total distance between two plates is D. Thickness of the dielectric is just T. In that case, how will the total capacitance change? Initial it is equal to epsilon naught A by D. After inserting the dielectric, partially filled dielectric, it will change to epsilon naught A D minus T plus T by K. This will be the formula for partially filled dielectric. Okay, is that clear? Okay. Next is partially filled but in a different way. Okay, as you can see here, this is A, this side is B. One dielectric K1 is placed like this, another dielectric K2 is placed like this. This distance equal to A by 2, this distance equal to A by 2. Okay, and separation is D. In this case, we assume it as two parallel capacitors. Okay, we can assume it as two parallel capacitor, one filled with K1, another filled with K2. Here area equal to A by 2, distance D, area A by 2, distance D. So C1 will be equal to epsilon naught K1 A by 2D. C2 will be equal to epsilon naught K2 A by 2D. Depending on the area, like how area is split, you have to write it. Here I have put A by 2, A by 2. Sometimes it will be A by 3, then 2A by 3. So according to that you have to substitute. Okay. Since it's a parallel connection, we can simply find C equivalent equal to C1 plus C2. That you will get as epsilon naught A by 2D into K1 plus K2. Okay, in this case we can split like this. At the same time, if it is split like this side is A, this side is B, K1 is this and K2 is this. Okay, so total distance is D. Let's say this distance is D1 and this distance is D2. In that case, you can split it as two capacitors connected in series. So here it is K1 with the D1 distance, A area. Here it is K2 with the D2 distance and A area. C1 will be equal to epsilon naught K1 A by D1. C2 will be equal to epsilon naught K2 A by D2. Since it is series connection, 1 by C equivalent will be equal to 1 by C1 plus 1 by C2. Further, after substitution we can say that epsilon naught A into K1 by D1 plus K2 by D2. 1 by C equivalent. Understood how we are splitting these? Is anybody having any doubt regarding this one? Okay, I guess not. We can move. Next one is like previously what did we do? Before the capacitor, like dielectric was not there in the capacitor. After we completely inserted, we are finding new capacitance. This is if you are inserting a dielectric to already charged capacitor. Last slide, okay. Do you have any doubt?
No, ma'am, just I want to write it.
Okay, okay. Is it done?
Yes, ma'am.
Okay. So already charged capacitor we have, in that we are inserting a dielectric. While inserting, there will be some force acting on the dielectric. What is that force? In that also two cases we can take. One case is capacitor is still connected to a battery. Okay, in that case we are inserting means force equation will be this. Okay, it is a constant value, it does not depend on x. If the capacitor is still connected to the battery, when you insert the dielectric, force will be constant value. Okay. Next one, when charge on capacitor constant, which means capacitor is charged but not connected to battery. Okay, capacitor is charged but not connected to battery, and we are inserting dielectric, force will be equal to this value. Here force will depend on x, like x is if this is the capacitor, its distance is d and area is a, and this is our dielectric, let's say. So this much distance is x, how much it has already inserted. So when it is removed from the battery and we are inserting, force will depend on x, this value. if we are still connected to the battery, force will not depend on X. Is that clear? Can we move to next slide? Okay. This is combination of parallel plates. Sometimes you will get capacitor questions like this. So you need to know how to exactly solve this. For in this case, here it is negative sign, here it is positive sign. We are supplying negative charges to this number 4, which means on both sides, okay, there will be negative charges for 4. Since 4 is having negative charge, it is attracting positive charge on the above one, right? So 5 will have positive charges here, okay. Now since 5 and 2 are connected together, since 5 took all the positive charges, 2 will remain with what? Negative charge, okay. 2 will have negative charge. If minus q charge is given to 4, this will be plus q. 5 will have plus q charge. Similarly, 2 will have minus q charge, okay. Now you can see this, here this two are having same positive charges, okay. Since the other ones are having minus q, this will have plus q, here also plus q, okay. All will have same charges but different sign we have to take. Now if you see, I will take another color, okay. This side of this one and this one will create one capacitor, okay. Next, this and this will create another capacitor, this will be another capacitor, and this will be another capacitor. It is like 4 capacitors connected parallel to each other, okay. And if you see, like this is also a capacitor, just that its other plate is at infinite distance. If you find capacitance, it will be 0. So we don't have to take this one and the top one. Other 4 we will see, okay. In the other 4, if you are connecting, you can connect it like this: 1, 2, 3, 4 capacitors connected in parallel. So total capacitance, equivalent capacitance will be equal to C1 plus C2 plus C3 plus C4, like that, okay. Did you understand how we are approaching this question? Okay. Okay, you did not understand, Dheeraj. Do you want explanation in Hindi or English?
No, any language.
Any language, okay, fine. See, here what the thing is, it will be connected like this, okay. Sometime they will show parallel plate connection like this. In this, what we will do is that if this side is plus, let's say this side is minus, we can say that these both plus charges will be distributed over 2 sides of this sheet, right? It will be like a sheet. Charge will be distributed over both sheet. Same way, this side also plus charge will be distributed on both sides. Now, if there is no negative charge here also, if there is no negative charge provided, because of the attraction, same amount of negative charge will be distributed in these, the other one, okay. Now in this, you can take these two, a pair like plus and minus, as one capacitor, then this side and this side as another capacitor, then this side as 3 capacitors. So this will act as 3 capacitors connected in parallel, okay. Now if I want to show in a like different manner, it will be like this, okay. Here this side and this side one capacitor, this side and this side one capacitor, this side and this side one capacitor. It will act in a way that 3 capacitors are connected in parallel. Now is it clear? Okay. So that is combination of parallel plates. Now this is some other type of capacitors, that is cylindrical capacitor and spherical capacitor. You only have to know this formula, okay? What will be capacitance of cylindrical one, what will be capacitance of spherical one. Direct formula only you need. So if you know that, we can start the problems. Is it fine? Please note down the formulas, then we can move to the problem solving. I guess we can move on. So see the first question. The plates of a parallel plate capacitor are separated by D. Now 2 slabs of different dielectric constant K1 and K2 with the thickness 3 by 8D and D by 2 respectively are inserted in the capacitor. Due to this, the capacitance become 2 times larger than when there was nothing. If K1 equal to 1.25 K2, value of K1 is. This is the question, okay? So initially there was a capacitor with the D distance in between. Its capacitance will be epsilon naught A by D. Now what they did is, in that capacitor they inserted 2 dielectrics, okay? 2 dielectrics they inserted. One is having distance 3D by 8, another is having distance D by 2. One is having K1, another K2. Okay. Now this one is having new capacitance, that is equal to 2C. They are asking what is the value of K1. Relation between K1 and K2 is given. As I told you, if this type is coming, we will split it as capacitor in series. But see, there is free space K1, K2. 3 things are there. Free space K1, K2. So we will split it into 3 capacitance connected in series. First one will be having K1, area A, distance 3D by 8. Okay. Second one having K2, area A, distance D by 2. Third one will be having nothing in between them, but what will be the distance? This distance will be equal to D3 will be equal to D minus 3 by 8 D plus D by 2. This much will be here. If you see that, you will get it as 8 by D. Okay, when you calculate this, you will get D3 equal to D by 8 area A. For here we can find C1, C2, C3, and you can find equivalent resistance C. Okay, so C1 will be equal to K1 epsilon naught A by 3D by 8. C2 equal to K2 epsilon naught A D by 2. C3 equal to epsilon naught A D by 8. This is the value of C1, C2, C3. Now 1 by C dash, which is equal to equivalent resistance of this combination, equal to 1 by 2C. Okay. If this you can write as epsilon naught A by D is C. So this can be written as 8 by 3 K1 into C. This can be written as 2 K2 C. This can be written as 8C. Okay. So 1 by 2C equal to 1 by C1, that is equal to K1 C into 3 by 8 plus 1 by C2. that is equal to 1 by 2 K2C plus third one 1 by 8C. C you can cancel out in every term and substitute K2 equal to K1 by 1.25. 1.25 can be also written as 5 by 4. So K2 equal to 5 by 4 K1. Substitute this and cancel out C, you can find value of K1. This is from NEET 2025. Okay. Did anyone get any answer? Answer is 2.66. Okay. When you solve it, you will get answer 2.6. Can we move to the next question then? Is anyone having doubt regarding how we solved this? I guess not. So let's move on. Next one. A parallel plate condenser is same as capacitor, is filled with two dielectric as shown. Area of each plate is A and separation is T. The dielectric constants are K1 and K2 respectively. Its capacitance in farad will be. You have to find the capacitance of this combination. It is like this, okay? K1, K2. What will be the answer? You guys tell me. Option C. Are you sure? Here,
Option A.
I think you guys are making small careless mistake. This distance is T for both. Here area will be A by 2. Here area will be A by 2. Okay. And we have to take C1 will be equal to K1 epsilon naught A by 2 T. This will be equal to K2 epsilon naught A by 2T. Since this will be parallel connection, we can directly add them. So we will have epsilon naught A by 2T into K1 plus K2. So they just written in a different way. Answer is option B. I hope you understood this. Okay. Like small careless mistake might be coming. Please pay attention. Okay. Next one, a 12 picofarad capacitor is connected to 50 volt battery. The electrostatic energy stored in capacitor in nanojoule. Nanojoule means into 10 to the power minus 9 joule. So you find this A. Energy stored in capacitor. Direct formula question only. What is the formula? What is given? C is given, V is given. So energy is equal to half C V square. Direct formula. Last question, why area get half? 1 second guys. Here see. See they have given half. Distance is half and half. Which means plate is split into two halves. So one half will have area half only. No. Like that we are separating. See, here also a distance, here also a distance, which means this is half the plate, this is half the plate, like that. Okay. This one, what is the answer? Yes, 15 is the correct answer. Okay, I hope everybody got. Like, once you calculate this, then you have to write in this way, 10 to the power minus 9 form, because they asked in nanojoule. Next one, figure shows charge Q versus voltage graph for series and parallel combination of two given capacitor. So one is for series combination, another is for parallel combination of two capacitor. What are those capacitance? That is the question. Okay. C, Q, V. What is the relation between these? C equal to Q by
V.
Yes. So we can use that formula. If you are finding B, for B, capacitance of B is equal to, at 10 volt it is having 80 microcoulomb. Okay, so 80 mu C divided by 10, that will be equal to 8 mu farad. That is CB, B graph. For A graph, if you take for 10 volt, 500 microcoulomb. Okay, so CA is equal to 500 mu C by 10, which is equal to 50 mu farad. Capacitance increases when connected in parallel, right? Because C1 plus C2 will come. And in series connection, 1 by C1, 1 by C2, it will be small value. So this is series connection and this is parallel connection. Same to capacitor, which means this we can say CB is equal to C1 C2 divided by C1 plus C2, series combination. And in parallel combination we can say CA equal to C1 plus C2. So from this you can get C1 plus C2 equal to 50 mu F. From this you will get C1 C2 by C1 plus C2 equal to 8 mu F. Since C1 plus C2 you can substitute as 50, this finally you can convert as C1 C2 equal to 50 into 8. What will be this value? It is equal to 400. Okay. Now if you add, you should get 50. Two values, when we add we should get 50, when we multiply we should get 400. Which is that value? Yes, somebody already got the answer. Kiran, good. A is the answer. 40 and 10, when we add we will get 50 and when we multiply we will get 400. I hope you understood that. Is it clear for all? Okay, otherwise sometimes if options are not there, your CBSE exam and all, using these two you will have to solve for C1 and C2. Okay, but since options are given, it is easy for us. We just have to compare the values here. Okay, moving on. Next one, in steady state, the current in the circuit shown below is, see, that is the code, steady state, which means switch has been on for a long time. What will happen? I told you. For steady state, how will the capacitor behave?
Current 0.
Yes, current through this branch, okay, will be 0, which means it will have only this. Circuit will be like this, 10 volt, 2 ohm, 3 ohm. Okay, so total resistance 2 plus 3, 5, 10 by 5, 2 ampere. Somebody already answered. Surabhi, yes, correct. Okay, everybody understood this? Code is steady state. When steady state term is there in the question, Directly assume capacitor is having no current through it. That branch will have no current, rest will be easy to solve. Okay. I hope nobody is having doubt. Next one. Effective capacitance of parallel combination of two capacitors C1 C2 is 10 mu. When these capacitors are individually connected to voltage source of 1 volt, energy stored in capacitor 2 is 4 times that of 1. If capacitors are connected in series, what will their respective capacitance be? Like it is easy, but more steps will be there. Okay. First, it is given that when they are connected in parallel, their total equivalent capacitance is 10 mu f, which means C1 plus C2 will be equal to 10 mu f. Now they are connected separately to 1 volt. When they are connected to 1 volt, some energy will be stored. C1 is having 4 times less than C2. So energy stored in 2 is equal to half C2 V square. V is 1, so we don't have to write that. Half C2. And energy stored in 1 will be equal to half C1. Again, V is 1, so 1 square I am not writing. What is given? Energy stored in 2 is 4 times energy stored in 1. From that, what will you get? Half C2 will be equal to 4 times half C1. Half cancel. C2 equal to 4 C1. We got this, right? We can substitute that here and solve for C1. Then you can find C1 C2 by C1 plus C2 will be equal to what? Again got the answer, very fast, good. Okay. So substituting this here, you will get C1 plus 4 C1 equal to 10. 5 C1 equal to 10 means C1 equal to 2. If C1 equal to 2, C2 will be equal to 8. Right? C2 equal to 4 C1. Then you can substitute that here, C1 C2. 2 into 8 divided by C1 plus C2 already given 10. So 16 by 10 equal to 1.6 answer. Is it clear for all? Okay. Moving on to next question. In the following circuit, equivalent capacitance between terminal A and terminal B. Okay. So you can see this type of thing, if it is coming in Wheatstone bridge, like in current electricity, we will assume it as a Wheatstone bridge, right? In capacitance also it is applicable. Why? Because see, here potential, let's say it's VA, here it is VB. Okay. Same amount of potential will be lost in these two cases. Like 2 mu f will take same V, right, across it. So at these 2 points, potential difference is same. So there will be no current passing through this branch. Yes, already got the answer, Surabhi. Good. So this can be considered as 2 capacitors in series, then connected in parallel. Okay, 1 by 2 plus 1 by 2 1, then 1 plus 1 2. Total 2 mu f is the answer. Okay. Is anyone having any doubt regarding this? If you did not understand the voltage one, think like this. Wheatstone bridge is applicable in capacitors also. Okay. Can we move on? Okay. Next one. If a slab of insulating material 4 into 10 to the power 5 meter thick is introduced between the plates of a parallel plate, distance between the plates has to be increased by this value to restore to the original value. Then dielectric constant of the slab. Question, understanding it might take time, but it's very simple. Initially there is a capacitor. some distance d between them, area A, and there is nothing filled in between. Its capacitance C equal to epsilon naught A by T. Now they introduced an external dielectric, okay, external dielectric they introduced of some value K, and that dielectric's thickness is, okay, dielectric's thickness is 4 into 10 to the power minus 5 meter. Then what happened? It will have some other value C dash, right? But what they are saying is that they increase the value, they increase the width as what? D plus 3.5 into 10 to the power minus 5. When they increased it by this much, you got C dash equal to C. Then what is the value K? That is the question. Okay, we know epsilon naught A by D is C. For new one, what will be C dash? C dash equation will be epsilon naught A, then K is there, right? It's not completely filled, it's partially filled. So its equation will be D minus T plus T by K. In that case, this D is actually this value, okay, D plus. So this equation will be epsilon naught A divided by D plus 3.5 into 10 to the power minus 5 minus T, which is equal to 4 into 10 to the power minus 5 plus this 4 into 10 to the power minus 5 divided by K. This is equal to epsilon naught A by D. This is the question. You have to find what is the value of K. That's it. This is the only equation there is. From this epsilon naught A will get cancelled. Then you can cross multiply, okay, and find. B. Let's see. Did everybody get that answer? Okay, not B. A. 8. Okay. Were others also able to solve? Yes. Okay. The answer is 8. This is the method to solve that. I hope everybody understood this problem. Can we move on to the next one? Okay. Next one, it's a conceptual question. It should be easy for you. If the plates of parallel plate capacitor connected to a battery are moved close to each other. So, capacitor connected to battery. Now we are moving the plates close to each other. What will happen? Some options given, which is correct among them. Let's see without my help if you are able to get the answer or not first. Okay, capacitance is equal to epsilon naught A by D. Here what are we doing? We are compressing, like bringing it closer, right? So D is decreasing. D decreases, C will increase. D decrease, C increases. So capacitance increase, that is correct. Now first one, charge. About charge they are asking. Charge is equal to CV. It is still connected to battery, which means V is constant. V constant, C increases, Q will also increase, which means A is also correct. Okay. Now next see, if you see the options, A, C and D, A, B and D. We can check if B is correct or not. B, energy stored in it decreases. Energy equation is half C V square, right? V is constant, C is increasing. Energy should also increase. C is increasing. So B is wrong. So our answer will be ACE. Sangeeta, don't make careless mistake. Okay. Energy will increase, and E, product of the charge and voltage increase. Charge is increasing, so Q into V should increase. Okay, like that. Is there any doubt regarding this? Okay. Next one is a combination of capacitors. What their question is, what is the capacitance value, what should be the value of C so that equivalent capacitance between them is 1 mu F. So between A and B, capacitance is given, it is 1 mu F. For that, what should be the value of C? That is the question. Okay. Now let's redraw this one. Starting from A, okay. First C is there. Then it is split into 2, right? First here 1, then here 8. 1 is then going and splitting into 2. Here it is 4, here it is 6 and 12. Okay. And it is going to B. Then here it is coming and splitting into 2. Okay, this is 2 and this is 2. This is also joining B. This is the figure. Okay, whatever is given is the capacitance of that particular capacitance. Now solve this and find the value of C. Total equivalent capacitance is 1 mu F. Okay, here 6 and 12 in series. So 1 by 6 plus 1 by 12. It will be equal to 2 plus 1, that is 3 by 12. If you take reciprocal, it will be 4. So this will become 4 and 4 in parallel. For parallel we will directly add. So this will become 8. Okay. So this we can remove and replace it with 8 mu F. Now here 2 plus 2, it will be 4. So here also we can remove and replace it with 4. Here 1 plus 1 by 8 reciprocal, or 8 into 1 by 1 plus 8. Here what you will get? 8 by 9. Here then capacitance will be 8 by 9. Here 8 into 4 divided by 8 plus 4. 8 into 4, 32. 32 by 12 will come, right? 32 by 12. Now we can add these two, then reciprocal and add to C. You will get the answer. Okay, somebody already got. So Surabhi, A. Let's see. I think A is only correct. I hope everybody understood how we are reducing the circuit into. Now add this, take reciprocal, add with 1 by C and equate it to 1. Okay, that is the next step. Answer is option A. Very good. Is it clear for everybody? Okay. Next one. The equivalent capacitance of the arrangement shown in the figure. Very easy one. You don't need my help at all. Just find the equivalent resistance here. Sorry, equivalent capacitance. D. Yes, very good. Correct answer. Okay, 15, 15, 15 in series. Okay, which means 1 by 15 plus 1 by 15 plus 1 by 15, that is equal to 3 by 15. It will be 1 by 5. So when you take reciprocal 5, then 5 and 15 parallel to each other, 5 plus 15, 20. Okay, answer is 20 mu farad. Is it clear for everybody? Okay, moving on. Next, capacitance of 2 mu farad is required in an electrical circuit across potential difference 1 kilovolt. A large number of 1 mu F capacitors are available which can withstand a potential difference of not more than 300 volt. Minimum number of capacitors required to achieve this. This is our, like we did m rows, n number of cell grouping, right? N rows are there, m cell in each row, like that. It is the equivalent in capacitors. What they are giving? Total capacitance, like equivalent capacitance, 2 mu F is required. Okay, and what is given? Total voltage across will be, V will be equal to 1 kilovolt or 1000 volt. We have 1 mu F capacitors, like n number of capacitors are there, each are having 1 mu F C. Then one can withstand a potential difference maximum 300. So what is the minimum number of capacitors required? So if V potential is applied, it should be distributed among some capacitors, right? Okay, it should be distributed among some capacitors. So how many capacitors are required to split 1000 volt? One capacitor can take 300. So n into 300 should be greater than 1000. Okay, number, like n capacitor we can connect in series, it will split the 1000 volt. So n into 300, number of capacitor in one row should be greater than what? 1000 volt. So should be greater than 1000 divided by 300. This you will get as 10 by 3 or 3.33. We cannot put 0.3 capacitor anywhere. So we will relate to next round figure, that is 4. From this we can get n should be equal to 4. Okay, like that n capacitors connected in series. So in one row effective capacitance will be equal to C by n. Like that m number of rows are there. So it will be m C by n, that will be C equivalent. It is given as what? 2 mu F. Individual capacitance is given as 1. Then we can write m into 1 mu F by n equal to 2 mu F. Okay, then n we found as 4. So when we substitute we will get m equal to 8. So m and n we got. N number of capacitor in m row. So total number of capacitor is equal to m into n. 8 into 4, that is, okay Sangeeta, very good. 2. Okay, answer is B, 32. Total in number of capacitors. Okay, you meant option 2 or C? Oh. Are you having any doubt in this one? Like total volt will be split in series. Series connection will have voltage split. So each will reduce 300 volt. So n number of capacitor we should connect in series. So n into 300 should be equal to 1000. If we are taking, we will get 3.33. but it is not a number. We need a whole number, so we will relate it to 4, next whole number. Then for rows we need total equivalent capacitance 2 mu f. Substituting there, we will get m equal to 8. Total number of capacitor will be m into n, that is 32. Okay, 4 into 8. I hope everybody understood that. Do you have any doubt? Okay, if not, we can move on. Next one. The effective capacitance of two capacitors are 3 mu f and 16 mu f. They are connected in series and parallel respectively. Capacitance of two capacitors, which means when they are connected in series and parallel, their capacitance is this. What are their individual values? So C1 C2 by C1 plus C2 connected in series, okay, it is equal to 3 mu f. When connected in parallel, it is equal to C1 plus C2, it is equal to 16 mu f. Find C1 and C2. But the potential is more than 1. That is fine, no. Like 1 can maximum withstand 300. It can withstand less than that also. It's fine, right? Option D. Okay. How we are getting? We will get that C1 plus C2 should be 16. Then C1 into C2 should be 3 into 16. Like that we can solve. Okay. Option D is the answer. Surabhi, did you understand? Like total potential we are applying is 1000 volt. If one capacitor can maximum withstand 300, if I am keeping 4, it will split equally. Like one will have 250 volt only, less than 300. That is fine. Now you understood? Okay, total across this will be 1000 volt. Individually, so across it will be 250 volt, right? It is less than our 300 volt. So that is fine. It should not go more than 300. One capacitor cannot stand more than that. That is the question. Is it clear? Okay. Next one. Capacitor of capacitance 900 picofarad is charged fully by 100 volt battery. Then disconnected from the battery and connected to another uncharged capacitor of capacitance 900 picofarad. Electrostatic energy stored by system B. So you have to find energy in system B. So energy in system B is equal to half C equivalent into V square, whatever be the potential. C equivalent is C1 plus C2. We can do that, okay. C equivalent equal to C1 plus C2, which is equal to 900 plus 900, 1800 picofarad. Picofarad is 10 to the power minus 12, okay. Pico is 10 to the power minus 12. Now we need V. What will be the potential? So it is charged by 100 volt battery. So maximum voltage for this is 100. Now when it is connected, since both are having same capacitance, we can say it will become V by 2. We can say that, but with respect to our formula also we can derive. V will be equal to C1 V1 plus C2 V2 divided by C1 plus C2. If you apply this formula, you will get 900 picofarad into 100 plus 900 picofarad. Second one is uncharged, which means potential is 0, divided by 1800. If you see this, you will get it is equal to 50. Okay, you will get it is 50 volt. So substitute V equal to 50 also and C equivalent equal to this. You will get the answer. Energy. Yes, option C is the answer. Very good. Okay, your calculation should be this fast. Okay, for NEET, when you are attending, do you know the concept or not is one thing. Next thing is your calculation should be fast because you have 1 minute to solve a question there. Next, moving on. I hope nobody had any doubt in previous one. This is the last question for today. Capacitance of a parallel plate capacitor with air as medium is 6 mu f. With introduction of a dielectric medium, capacitance became 30 mu f. Permittivity of the medium is. Okay, initial C is equal to 6 mu f. When you introduce a dielectric, new capacitance will become Kc, right? So this is equal to 30 mu f. From this we can find K equal to 5. This is our first step. Next we have to find permittivity, right? Permittivity of the medium divided by permittivity of space is our K, dielectric constant. So medium's value is equal to 5 into epsilon naught. Okay. What is the answer? Epsilon naught value is already given in the question, so we don't have to worry. Anyone got the answer? B. Okay, so here you can see that they have given 5 also. It is to confuse you because maybe when you get 5 here you might directly give the answer. That's why. So just make sure you are reading the question properly and finding out exactly what they are asking. Okay, I hope everybody understood this. Answer is option B. Very good. So that is for today's class, and since capacitor is a very small chapter, there are no much more questions to be asked from this. Every question will be of similar pattern only. Please try to do some more on your own, and if you are not able to solve, you can reach out to me at any time. I guess that's for today. You can leave the class. Join back at 12 for chemistry class. Thank you all.